Is it just edu over 1 plus edu, not squared?
Say that again.
Is it just edu over 1 plus edu, not squared? Plus c?
Well, we still have to show that we are using a substitution. Let's say let y be what we want y to be. Right. So then dy equals e to u du, which is right here. And this is y squared. Excellent job. So this is the integral from du dy over y squared. Which function prime is 1 over y squared? That's why I insisted a long time ago to remember this.
2ln.
Careful. If I had the integral from 1 over y dy, yes, I would have said natural log of the absolute of y plus c. But that's not the case. It's y squared. Which function prime is 1 over y squared? Okay? I know you know because we just used it. We just used it a couple of minutes ago. And I know you know. Negative 1 over y. Yes. Very good. So it is negative 1 over y plus a constant c, which is negative 1 over 1 plus e to u plus c. Savannah, is this what you said?
Yeah, do we have to use substitution?
You don't have to use substitution, but I don't remember you saying the negative in front. So be very careful. Be very careful. So I'm fine if you don't use substitution. If you can come up with the answer somehow without a substitution, I'm fine. But the negative would not be there. So be careful on that. That's why we really want to go through the substitution because it makes our life easier and also prevents us from making mistakes. Yes, Braden?
Do you understand, or how do you get dy again?
Once I have the function, I can get dy. dy by definition is the function prime times du. So the function prime is e to u times du. This is dy is not the derivative, it's the differential. And the formula for the differential is f prime of x dx. I don't have x, I have u. So it's f prime of u du. Other questions here on this problem? Other questions? Anything? Other questions? Okay, excellent. We move on to D. So the integral from cosine to the fourth x sine x dx. Ready? Any suggestions on this? Any suggestions?
Cosine.
So dy equals?
Negative sine x dx.
I don't have the negative. Now I do. Yes, Ricky?
Why
Very good. Don't write anything. Let's try that. Let's try that on the side. So if I have y cosine to the fourth dx, then I have dy equals 4 cosine to the third times sine, sometimes negative sine x dx. So I have to have the 4, which is not a problem. I have to create the cosine cubed. I don't have to create the sine because it's in the problem, but I don't have cosine. So once I replace this by y, I have to create a cosine cubed, and there is no way I can. Better? I'm not saying that we may not find two different substitutions that work. We may. But in this case, this one does not. Is that clear? So the substitution that we use has to simplify the function. If it doesn't simplify it, it's not the right one. If dy is not in the problem, then it's not the right substitution either. So two conditions. It has to simplify the function, and dy, or d variable that I use, u, y, whatever, must be easily makeable in the inside the integral. So see, in this case, the only thing that I'm worried about is the -1, no problem. I can always make up a -1, even a 4, but I cannot make up a cosine cubed. Good. So then the integral becomes negative outside. This piece, this, and this. These three pieces make up the dy, and this piece is to the, exactly, y to the fourth. So then the answer is negative y to the fifth over 5 plus a constant c. And because it's an indefinite integral, I must go back to the substitution. So it's negative cosine to the fifth x over 5 plus a constant c. We have to go back. Yes, Ricky? I have the negative from the front. I copied it. So when I integrate y to the fourth, I have to increase the power by 1 and divide by that number. So the integral of y to the fourth is y to the fifth over 5. Yes, I have to replace y by what I used in the function, cosine. Yes. Any questions? Yes, Brayden?
I'm just confused on the last part.
Yes.
Like substitute it back in.
I have y equals cosine. I have y here. I just have to replace it by cosine.
Okay.
I have to go back. I cannot give the final answer in y. Y is our creation, right? We used y to simplify the function and make our life easier. But the final answer has to be in cosine, which is not, say it again. Say that again. Very good question, actually. Yes. Okay. Two functions can look totally differently but have the same derivative. Yes, that's a very good question. So did you understand Savannah's question? She said, okay, I find the integral of a function to be blah, blah, blah. Can somebody else come up with a totally different answer with a totally different function? The answer is yes. Because two functions can have the same derivative, but they look totally different. If you ask me to give an example right at this moment, I have to look it up. I won't be able to give you two functions that look differently and have the same derivative right this moment. I will have to dig it up a little bit and find two functions. I can show you. But yes, the answer is yes. Excellent question. Good. But you didn't get a different function for this one. Good. So we're moving on to E. The integral from 0 to 3. 1 over 2x minus 1 dx. Say it again. This one is a definite integral because it has limits of integration. So the answer will not be a family of functions, but one simple number, or not. So, any ideas?
to the -1?
You know, it's on interval. So it would be
Function undefined.
Wow.
Undefined. Fundamental theorem of calculus not applicable because x cannot be 1/2. Very good. Next one. Please remember this is a must. Every time we even think of applying the fundamental theorem of calculus, we have to make sure that the function is continuous.
isn't this one 0?
Say it again.
Isn't this one 0?
Yes. Why is this one 0? I have to write two different things have to be mentioned.
Symmetrical and off.
Symmetric.
And that's a product of an even and odd function, so it's an odd function.
Very good. An odd function. Excellent. Very good. Well done. Here's the next one. We have the integral from 0 to 8. Ask, please, if you have any questions, please ask. No one can find the antiderivative for this. Don't even try. So we can still find an approximation, maybe not a perfect approximation, but at least an idea, an approximation of this integral. And of course, I'm not going to ask you to perform something like this with more than 4 subintervals. I just want to see the technique. I don't care for the final answer, Jared.
Can you explain what that 0 means?
Yes. So when we talked about the properties of definite integrals, we said that if a function is odd, like for example x cubed is odd for you. Sorry, this is what this is x cubed.
I understood.
Sorry. Okay, so if I determine the integral from x cubed from -3 to 3, this piece will be positive and this piece will be negative. So they will cancel out. So the answer is the same thing here. So the function is odd and the interval is symmetric. If the interval were not symmetric, then the answer would have not been 0. It would have been either a positive number or a negative number.
Granted, can't you still do it the normal way, as long as it's continuous, and you'll end up with 0? Or would you?
It's a very good, excellent question. However, this particular integral requires integration by parts, which is a technique that we learn in Calc 2. It's the first among the first few chapters of Calc 2. So it's called integration by parts. We cannot do it in this class. I can show it to you, but we cannot. It's not a technique that we learn in this class. All the other techniques are integration by parts and trig substitutions. They're all in Calc 2. Okay, ready for this one? So here we don't know. We cannot determine f of x, which is the antiderivative of this function. So we can plug in 8 and subtract when we plug in 0. Nope. This doesn't work. But we can still come up with some number that represents this integral, some approximation, and we're told to use the midpoint rule with 4 subintervals to approximate this integral. 4 decimal places, please. Well, maybe it's not even needed. Let's see what we come up with. So, any suggestions on how to start?
So the x would be 2.
So yes, so we look at, very good. We look at the interval between 0 and 8, and we split it into 4 subintervals. Yes, 2, 4, 6. But we're asked to use the midpoint.
Right.
So what is this?
So that's
1. What is this? Okay. What is this? Very good. So then the integral from 0 to 8 from sine the square root of x dx is approximately delta x. What is delta x? b minus a over 4. b minus a over 4. How much? Of course, 2. And then we have 4 items here, or terms. First one is f of, very good. Next one. Very good. Next one. Very good. And the last one? Right. So let's put this in the graphing calculator. We're not going to do this by hand. Okay. So here's what I would like to do in stats and edit. List L1 is just 1, 3, 5, and 7. 1, 3, 5, and 7. Okay, the mouse is glued somehow. 5. Oh no, don't do this to me again. Okay. Let's try again. So go to edit, stat, edit, and list L1. Let's try again. 1, 3, 5, and 7. In list L2, at the very name of the list, we have 2 multiplied by sine the square root of list L1. Close the parenthesis outside. So when I press enter, I will get 4 numbers. What will those numbers be? 2 from the front, some sine of 1. Make sure I didn't check yet, but I'm pretty sure that the mode is in radians. It has to be in radians. Okay. So then the next one would be 2 times sine the square root of 3, and the next one, and the next one, and the next one. Okay, so let's do that. Press enter. So now all I want is the sum of these numbers. And if you remember, I showed you last time, we go to stats again and calculate one variable stats, but careful, it must be on list L2 and calculate. And this is 6.1820. It says 6 decimal places. I'm going to write 6.182037. 6.182037. Do you need me to show the procedure one more time?
Yeah. You can also click second stat and then go over to math, click sum, and then just type in L2.
Okay, so that's another way. Very good. So we want to go to the math.
Second stat and then math.
Okay. So second and stat.
And then over to math.
Over to math, and we want the sum. Perfect. And we want the sum of list L1. L2, sorry, of course. 6.182037. Great job. Thank you. Any questions on this? Thank you, Braden. Any questions? Okay, moving on. Find the displacement and total distance covered by a particle moving along the line given its velocity. So we did this a long time ago with that particle moving back and forth. So we're given the velocity 2t minus 4, and the interval is between 0 and 6. So this time, do you remember that situation with the particle moving back and forth, and we were adding this absolute value and so on and so forth? There is no need to do that anymore, because now we know that the total distance will be the integral from 0 to 6 from the absolute value of v of t dt. At that time, we did not know integrals, so we could not determine the distance like that. But now we know. So this will be the integral from 0 to 6 from the absolute value of t minus 2t minus 4 dt. Okay, that is all good. But now I have to look at this function, which is the absolute value of 2t minus 4. which we know like any absolute value. So let's go back for a moment to the formal definition of the absolute value. From any expression, what are the options?
Positive and negative.
Exactly. Positive the expression if the expression is positive or 0. And the other option is negative the expression if this, same thing, if the expression is less than 0. Notice that these are all the same. Do not change anything. In 5 different spots, we will have the exact same quantity. So then, the absolute value of 2x minus 4 can anyone dictate? Don't calculate anything, just dictate the preliminary step.
It's positive 2t minus 4, t is greater than
You're right, it was t. Sorry, thank you. 2t minus 4. If 2t minus 4 is greater to 0, excellent.
and negative 2t minus 4.
Yes, plus 4, because let's distribute.
Yeah. If 2t minus 4 is less than
Very good. So you see this and this and this, and of course it's this, but I also distributed -1, and this are all the same. I have to solve this inequality. Just one, because the other one will be the opposite. So then the absolute value of 2t minus 4 equals 2t minus 4 for t greater than or equal to 2. Would you agree? And negative 2t plus 4 for t less than 2. I don't have to solve the second one. If the first one is greater than or equal to 2, the other one must be less than 2. Mandatory. So coming back, I'm going to copy the integral here one more time. And please dictate. And I know you're going to dictate the sum of 2 integrals. So what is the first integral?
0 to 2.
Very good.
Negative 2 to
Is it clear why it's 0 to 2? Everyone?
yeah.
Okay, from 0 to 2, from negative 2t plus 4, agreed? Yes? Plus, from
2.
to 6 indeed, from good. So now if we can go back, I can, if we remember where it was, and or maybe you have it in your notes. I would like to go back to one of those problems. Maybe we also had a problem like this on the test, on test 2, and determine it now with an integral. So we can do that if you'd like. Okay, so then this is negative 2t squared over 2 plus 4t from 0 to 2, and plus 2t squared over 2 minus 4t from 2 to 6. So when I plug in 2, I get 4 with minus in front, and then plus 8. Luckily, I don't have to plug in 0. Plus, I plug in 6, 36 minus 24, minus, put parentheses so we don't forget to distribute, 4 minus 8. Now, these numbers are okay, but those with fractions and square roots and so on and so forth, I don't care for the final answer. If you want, wait till you finish the test. Okay, so this is negative 4. Let me just try and see if I can simplify anything here. So this positive 4, right? And this is plus 12. And this is plus 4. I got 20. Correct me if I'm wrong. So the distance covered by the particle between 0 and 6 is that integral from the absolute value of the velocity. And the answer is 20. Now, if you find that problem, we can go back and check the answer with the integral. Or if you want me to dig it up. Okay. Verified inequality using the properties of the definite integral. So we will not be able, don't attempt, you will not be able to determine the antiderivative of this function. Don't even try. And we are only asked to show that this is true. We're asked to show that 0 to 1 e to the x cosine x dx less than or equal to e minus 1. And then the last problem here is the derivative of this function using fundamental theorem of calculus part 1. Okay, so I would like us to work on this together. Where is our starting point here? What do you think? Excellent. Good. What is the next step? Or the next step? Yes, that's fine, but I really would like to continue with cosine. Why? Why do I look up at cosine? Because it's a bounded function. Bounded from below by -1 and bounded above by, excellent. So cosine x is a number between -1 and 1. Undoubtedly. Good. Now, because I already built part of the function, what do you think I'm going to do to all three sides to have the entire function in the middle? Say it again. Multiply by e to the x, all three sides. But now I have to be careful. I can do that only if e to the x is positive on 0 to 1. Poor e to the x is always positive. And if e to the x is not 0. Yes, it's not 0. E to 0 is 1, and e to 1 is e, so I'm safe. So the left-hand side is -e to the x, the middle is e to the x cosine x, and the other side is e to the x. Okay, so final step. What do I have to apply to all three sides?
The integral.
Good. I will disregard this part. Why? Because there is nothing on the left. They didn't ask us to do anything with the left-hand side. They only want the right-hand side. So I don't care for the left. So the integral from e to the x cosine x dx is this part. And it's less than or equal to, of course, these are all from 0 to 1. So which function prime is e to the x? So e to the x from 0 to 1. So the integral from 0 to 1, e to the x cosine x dx is less than or equal to. When we plug in 1, we get e minus, when we plug in 0, that's it. Any questions on this problem? Yes, right?
Why did the 2 to the right have intervals? Like,
Say it again.
the 2 intervals have intervals, but the one on the left doesn't.
You mean this one?
Yeah.
Yeah, of course. I just didn't write. You mean 0 to 1?
Yeah.
Oh, I cannot change anything. It has to be the same thing. I applied the same thing to all three.
Okay.
Of course. Sorry about that. Yeah, I cannot apply to the left-hand side something and to the middle and the right-hand side something else. Of course. I just completely disregarded it because our inequality did not have a left-hand side. Otherwise, it would have been there, and I would have had to keep it. Of course, yes, makes sense. Okay, the last problem on this handout, we have a function f of x, which is the integral from 2x squared to tangent x t squared over t plus 1 dt. Of course, they cannot ask us to do anything else but find its derivative. It's a function. How do I know it's a function? It's a function because it does not have the limits of integration are functions. And because it says so, we're only asked to find f prime. But I can't differentiate both sides before some prep. I need to prep this before I differentiate both sides. So what do I do?
You create a point between the two.
Yes. So first of all, I have 2x squared to whatever you want. 0, okay. From t squared over t plus 1 dt plus from 0 to tangent x t squared over t plus 1 dt. So this is the first prep. It's very good, but it needs one more little prep, one more step, which will be,
The constants.
careful, I have to change this.
Put a negative sign.
Yes,
And then put a negative.
yes, 2x squared, very good. T squared, t plus 1 dt, plus the integral from 0 to tangent x, t squared, t plus 1 dt. Now I can differentiate the left-hand side, and I can differentiate the right-hand side. And what do I get for f prime? As long as I do not plug in, or as long as I don't replace t by a function, I don't have to differentiate that function. But when I replace t by a function, I have to say times by the chain rule, I have to multiply by the inner function prime. And I'm ready when you are.
Negative 2x squared squared
Very good. Over.
1 plus 2x squared
Very good.
plus tan x
Multiplied by
Fourth.
4x
multiplied
plus
Tan squared.
over tangent x plus 1 times
Secant squared.
that's it. You don't have to do anything else. Yes, if you want to replace this by 4x to the 4th times 4x, so it would be 16x to the 5th, all these, because you have a 4x to the 4th times 4 is 16, x to the 4th times x is x to the 5th. Yes. Other than that, you don't have to do anything else. Yes.
So why did we, for the upper interval, or the upper limit, or the upper interval have 0, like just use any random number?
Yeah, any you want.
Why did we do that?
I have to split it. I have to split the integral. So you can, if you don't want to put 0, you can just put a, put a letter,
Okay.
which is a number. If you don't like that, put 10, put anything you want, any symbol. Because the lower limit doesn't count as long as it's just a number. Now, if it's a function, I cannot use the procedure. I cannot differentiate.
Okay,
Yeah.
So the lower limit is just
Must be a number.
and the
Any
upper
number, but a number. Yes.
function.
Yes. Never a function. That's why we're going through all these hoops, right? We are changing this into a sum of two integrals. Then we don't want 2x squared to be in the denominator, in the lower limit. We have to swap. That's why we go through all these. So only now the two integrals are ready for differentiation. Only when they have a number as the lower limit.
Then how did we differentiate it? I'm just confused on the steps.
Yes. So you mean how we differentiate this to get this?
Yeah.
Okay. Very good. So the fundamental theorem of calculus part 1 says this. A function can be given in the form of an integral. And if you remember, I showed why we plug in any number, we are getting a function here.
And it just goes away, leaves the function.
Right. Yeah, sort of. Yeah. So then when I differentiate both sides, the left-hand side is g prime. And the right-hand side, all that really happens is when I differentiate this and this go away, and f of t becomes f of x. So coming back to this situation, this is our x, right? So all I have to do is plug it in, and I did. So now it becomes this x squared, and it becomes x plus 1. However, it's not x, it's 2x squared, so that's why I have to multiply by 4x. So here I should have multiplied by x prime, but x prime is 1. Since this top is 2x squared, then here this has to be replaced by 2x squared prime. Is this somewhat better?
Yes.
Very good. Is there anything that you would like to go back to from what we covered in 4.9 and chapter 5? This pretty much summarizes all concepts. But is there any particular type of problem that you would say, well, I would like to see more? The Riemann function. You mean finding the exact area, or calculating sum of where the calculator as we just did, because we couldn't find the antiderivative? Just the Riemann sum. The Riemann sum? Okay, very good. So let's choose a function. Let's choose a function either linear or quadratic or cubic. We are restricted. So give us a function, linear, quadratic, or cubic, and give us an interval. We have about 6 minutes. We're going to start it, and you're going to probably finish it at home, because most probably in 6 minutes we will not be able to finish it. So can anyone give us a function and an interval? If you say sine x, we will not be able to present the limit of the Riemann sum with sine x. It only can be linear, quadratic, or cubic. We don't have those formulas that we have for sum of I squared, sum of I cubed, and sum of 1. We don't have them for anything else. So linear, quadratic. Say it again. You want x plus? Okay, you want a linear. Well, we would be able to finish in 5 minutes if we are looking at the linear function. Okay, interval.
2, 4.
Excellent. We need 3 preps. First prep, please.
dx.
Very good. Which is delta x, yes. Yep. So it's 2 over n. Good. xi
Is 2 plus 2i.
very good. F of xi, nice and easy.
2i over n.
2 plus 2i over n plus 4. This will be 2i over n plus 6. Is that agreed? Okay, very good. So then the area equals the integral from 2 to 4 from x plus 4 dx. And now I continue. I like to calculate it. X squared over 2 plus 4x from 2 to 4. I plug in 4. 16 over 2 is 8. 4 times 4 is 16. Minus, when I plug in 2, I have 4 over 2, which is 2. 4 times 2 is 8. So the answer should be 14. And now let's see if we get it. So the area is limit n approaches infinity from the sum I equals 1 through n from 2 over n times 2i over n plus 6. We will move 2 over n outside. So limit n approaches infinity 2 over n. And then when I apply the sum to this first term, I will put 2 over n outside, the sum of I, plus 6, the sum of 1. Let's stop for a moment and look at this. So first of all, I took 2 over n in front of the summation or sigma notation. And then I applied the sum to this, but I already took 2 over n outside. This 2 over n, sum of I, plus, this is 6 times 1. I apply the sum and I pull 6 outside, sum of 1. Now we know these two. n plus 1 over 2. And I know this as being n. Excellent. Any questions? Any questions? Okay. So this equals limit n approaches infinity, 2 over n, and now in brackets, 2 over n, n plus 1 over 2 plus 6n. Even the denominator disappears. How nice. 1 and 1, 1 and 1. So this is limit n approaches infinity 2 over n, and then this is n plus 1 plus 6n. There's nothing else. So 7n plus 1. Or limit 14n plus 2 over n From pre-calculus, we know linear, same degree over same degree. Leading coefficient, right? Let's say we don't know, we don't remember that. So it's infinity over infinity. We can apply L'Hopital's rule. In case you don't remember, it's 14 over 1. So the answer is 14, as expected. Because we determined the area using